Hey everyone, my name is Michael Stipe, and today I want to dive into the new data APIs that we introduced into GreenDonut with version 15. These new APIs are to leverage all the rich data APIs that we have in Hot Chocolate since forever, but in a layered architecture, like with clean architecture or whatever layering style you prefer. Before we get started, if you want to have the source code of this episode, or any other episode that we have on YouTube, head over to tv.chillicream.com. If you like our content, please hit the like and subscribe button below the video. And with that, let's dive in. So what is GreenDonut? GreenDonut is about data loader. It's a separate API that just deals with data loader. If you don't know what data loader are, you can head over to my episode I did on data loader basics, what they are, and why you should use them, that I also have on YouTube. So GreenDonut exists really like the first version of Hot Chocolate, and it has all the stuff that you need for implementing data loader. And GreenDonut doesn't have any tie-ins with Hot Chocolate, right? It doesn't reference Hot Chocolate, it's isolated. Hot Chocolate, on the other hand, does reference GreenDonut and uses GreenDonut for all the batching capabilities. So Hot Chocolate layers on top of GreenDonut. With Hot Chocolate 15, we introduced GreenDonut abstractions so that you can use the interfaces without referencing the implementation. But this is not about the new data APIs. This is basically the good old GreenDonut like we had it forever, just that we removed the abstraction into a separate package. With version 15, we also introduced a lot of new APIs. The GreenDonut.Data APIs. And these are about like rich data APIs in a layered architecture where you can move out certain aspects into your data layer or into your business layer. The only thing that is publicly exposed are the primitives. And these are very basic types that you can use to represent a page, for instance, if we are in a paging context. Or for describing selectors. Basically, a selector is an expression of what data you requested from the GraphQL layer. These things are described in the primitives. If we put that into layers, you would have in your application layer the GreenDonut.Data primitives. You could also get around without them, right? Then the primitives would also sit in the infrastructure layer. And you have to write a bit more mapping code in Hot Chocolate and also in your business layer to data layer logic. But this is also possible. We designed it in the way that you could do that. The easiest way, however, is to use the primitives and then it will just click into place in every of your layers. So what I'm going to show you today is how to use these new capabilities in GreenDonut.Data, but I'm not showing you how to integrate it actually with a clean architecture. That is a whole different session, right? So let's just jump right into it. So before I go into the C# code, let's actually have a look at our schema. In our new document tab, let's have a look at the schema. And when we go here to the query type, you can see that we have a couple of root fields to get our entities. This schema is built around a web shop. So we have brands, and from brands we can go to products. So each brand can have many products, and you can see there's no paging used here. And that is really the first aspect that we're going to change about our API. And we're going to use the cursor-based pagination that is best practice in GraphQL. So let's jump into our C# code and implement that. So in our C# code, you can see we have a types layer. This is where all the GraphQL stuff lives. And there we have a brand queries type, which has the resolvers to get the brands. And at the moment, you can see the return type here is a brand array. So let's not linger on that. Let's have a look at the other layers that we have here. We have a service layer. This service layer is very simple at the moment. We have, for instance, a brand service here. The brand service gets a data loader when we fetch the brand by ID here. And we also have here the get brands, which directly goes to EF Core and builds up the collection of brands that we want to return and orders it by name. Lastly, we have here a simple data layer, which is just EF Core. So what you can see is that we map here our brands. So in our business layer, we have a different type. For instance, brand here is just the read model, whereas in our EF Core layer, it's called brand entity, just to have also the mapping aspect in our solution in here. So let's introduce paging to our top level field here of get brands. So how could we do that? As I said, we have now primitives in GreenDonut. And the first primitive that we have is actually representing a page. So we could say, instead of returning here just a brand collection, which has no semantic of what it means, is it a slice, is it everything? We have actually a primitive called page of brand in this case. Let's import that. And with this, we declared that this is a page. And if we look at page, you can see it has also what's the first item, what's the last item. These two can be translated into cursors. We also have like indicators if there's a next page or has it a previous page, right? So it represents all the aspects that we need in GraphQL or in any other API to deal with cursor-based or key set pagination. Okay, the second thing that we need to kind of pass into our business layer is actually what slice we want to have. And what slice we want to have is defined by paging arguments. Let's call that paging args, and that is what you have to pass in for us to build that page. And this again has the typical parameters like first, how many items do you want to have? After, which is a cursor to get the first like 10 items after a cursor. So the very specifics to cursor-based pagination. So with these two primitives in, how can we make it pageable? And that is really by just kicking out this guy here and saying instead of toArray async, toPage async. And this guy here comes actually in the GreenDonut EF core package. So if we go back into our overview, you can see we have a driver for entity framework at the moment for GreenDonut.Data. There are other drivers in the work, like for MongoDB, for Martin and RavenDB. So there's more coming, but at the moment it works with entity framework. So let's go back to our code and actually make sure that this is referenced. So because we have every of our layers at the moment in one project here, it's very easy. We just need the hot chocolate data entity framework package in here. So this guy. And when we restore that, then the GreenDonut.Data entity framework package is referenced by this package. As I said, hot chocolate in general already references GreenDonut for batching in the execution engine. And the hot chocolate data entity framework package references the GreenDonut.Data entity framework package. So by just having this in, we reference all of this implicitly. If you have a more layered design where you have specific assemblies or specific projects for each of your layer, then you can directly reference the GreenDonut.Data package. So with this done, you can see now we have this extension method here. And basically we are done, right? We have everything that we need for paging here implemented in our business layer. And then we can go to our types layer, to our GraphQL types layer, and just amend that. So in GraphQL, we don't know about page. That is a GreenDonut thing to describe abstract what a page is in a key set pagination scenario. But in GraphQL, this is actually called a connection. So we have a connection of brand. When we get that here, this guy, get brands async, we have to map it to a connection. So we would say to connection async. Awesome. This is already working. We can see that we still have to pass here the paging args in. And in hot chocolate itself, we would have something that is the cursor pagination arguments, right? This is what we have natively in hot chocolate, but we can map that actually to the paging arguments that we have in GreenDonut. So we say, we want to have the paging args here and pass them on to our business layer. So, and then we go to our GraphQL builder and register actually this mapping. So we go here to the program CS, and then we can say add paging arguments. So in the hot chocolate data package, we already have this mapping specified. And the hot chocolate data package is referenced by the hot chocolate data entity framework package. So basically this translation of the primitives is mapped for every provider that there is or that there is in future. So that's why it's in the base package. So with this done, there's one more thing to do, and that is actually go to our resolver here and put the paging middleware on top. So we say use paging in this resolver. So with this done, let's just simply start our server, go to Nitro, and then we're gonna refresh our schema here. And you can already see that we have now here brands connection. And we also have here now the paging arguments. You can see first, after, last, before. That's the typical paging arguments that we have. And you also see here the structure with nodes and edges. That is the cursor pagination structure. If you're building with GraphQL, you need the right support to stay ahead. The Chili Cream support plans give you direct access to our experts, priority bug fixes, and even a say in our roadmap. So you can shape the future of the tool you are relying on. Check out the options to find the right fit for your team. And with that, let's go back to the problem at hand. So we can now query our thing. So we go here to brands and then we go for the nodes. We take the name of the brand and then we want to have the first 2 items. So we're going to run that. You see we get the first 2 items. And if we look at the SQL here, we get a very simple SQL that selects basically all fields of brands, orders it by name, and then limits it to the amount that we want to fetch. But it also works like with actual cursors when we want to go to the next page. If we, for instance, say we want to have here the page info, get the end cursor, then you can see this is our cursor. We can grab it and then we can say we want the first 2 items after this cursor, after the end cursor, so after this item. And then we can run that and you can see now it's moving forward and we get a slightly different SQL where we use now the cursor value that we have here, which is built on top of the order, right? Keyset pagination uses the order to navigate, filter in on the dataset we want to have or on the entities that we want to have. And that's also why keyset pagination is so much more performant than offset pagination, because we do not do a skip, but instead do a where. And the database server is very efficient at doing this, right? They can do these filters very efficiently. They just filter in on this aspect and then you take the next 2 items very fast and has constant performance no matter how far you are in your pages. But this also introduces one aspect here. We need to make sure that this actually is unique, right? And if it's not unique, then we have to introduce to our order a part that is unique. So if brand name is not unique, then we should have the key as a then by. So we could just simply do a then by ID. If it's a composite keys, you have a couple of then bys, right? But taking together these values makes it unique, right? If we restart our server quickly, so this cursor will no longer work. This is a wrong cursor. It produces now random stuff here. So let's actually kick it out. Get asked writer here. You can see this cursor is now longer. So it has more values. Let's put in this cursor. Then we get again to the second entry here, to the second page. And you can see down here, we have a more complex where clause that also incorporates the ID. So it must be larger than name. But if we have the same name twice or thrice, then it must be larger than the ID that we are on. Awesome. This is the first aspect and it works in a transparent way. Our resolver is very simple. You can see the complexity has only slightly changed. We have now here use paging. We have this arguments, but it's basically one line of code. If we look at our get brands business layer method here, that does the execution of this query, this is also only slightly more complex because we need to make sure that the order by is always a unique or has a unique column that it works on, right? And then we have, instead of a 2 array async here, 2 page async. So let's take this further. So at the moment, we can dive here into the products, but we want to make sure that these products here are also pageable. And this is actually a nested call, right? If we run that, then you can see that we are at the moment actually using a data loader that does a group by here with complex logic on the data layer. Let's actually have a look at it. So I'm going here to the data loader for the product, and you can see here's a get product by brand ID data loader that, as I said, does here a group by, then selects here the group and does put an order by on the list and then maps it to a dictionary. So this data loader builds for all the brands that we fetch in one query, a single database query to fetch all of the products for each of the brands. So what we're going to do is we're going to rewrite that so that it works with paging. So as we learned in paging, we have actually a new primitive that is the page. So in our data loader, that's the lowest layer. That's where we're going to introduce it. We're going to produce, instead of an array, now a page of product. The second thing is that apart from the IDs, so apart from our keys, we're going to inject here the paging args. And then we're going to use that to do the same thing that we did in our business layer, to use a two-page async. But in this case, we cannot use a simple two-page async because we need to fetch that for multiple brands in this case. And that means we have to do a batch call. So let's get rid of these guys here and introduce here the order by. And in this case also do the then by with the ID to make it unique. And then instead of doing here the two-page async, we're going to introduce a two-batch page async. And you can see we need one more parameter for that. And that is actually the key. So our brand by ID key, by which we need to group it and from which we need to build this dictionary. So this is the key that we insert here. And with that, this call looks a lot simpler than before with all the group by logic. And we get now a page per brand, a page of product per brand. But this now has implications to our business layer. So we're going to go to the get products by brand method on the product service here. And then we can introduce here one more thing. So let's first say we're going to have paging arguments passed in. And then also here, we're going to return the page of products. So this still doesn't work, right? Because we need to pass on the paging arguments. And we can do that by using this wither method here to just pass on the paging arguments. And then instead of returning here an empty array, if there is no page of products, so let's say brands does not have a single item of products, then we would basically get back null from our data loader. In this case, we're going to return an empty page here. So we can say page product.empty. And with that, we replaced this functionality here. And we can now go wherever we use that. In this case, it was used here in the brand node. You can see this is the type for brand. And this is where we extend each of these brands with the get products resolver. So let's also say here we're going to use a connection of product instead of a product array. And then we also inject here the paging arguments, and we just pass that along to the service function that we have. And at the end, we just do a two connection async here. Okay, this looks also nice now. We just need to put the use paging attribute on top. And then this is also refactored to use now paging in a nested approach with two batch page async in our data loader. Okay, let's run that, refresh our schema. And then you can see now this type has changed because it's now the paging type, like with brands. We can ask now for the nodes and for the name. And we can also say, give me the first two products for this brand, right? And then we can run that. And you can see these are only two products for each of our two brands. And if we go here to the SQL, you can see this is the initial SQL to go to the second page of brands. And then we have the second SQL from the data loader that then selects the products that are for each of the brands there. And also does this by using here a limit. In this case, it fetches 3 rows just to see if there is more than 2 rows. So it overfetches slightly to see if it has a next page. Awesome. So this is nice. We now have paging integrated in our different layers. And again, the complexity only slightly increased. There's not a lot more complexity to it. Our product service, it's basically a single line here. It now has this additionally here. But apart from that, the data loader is essentially the same core that we have in our service layer as before. In the data loader, it actually is much more clear now. We don't have a group and a select by here. So this is actually simpler now. And in our brand node, I would also say it's not a lot more complexity. So let's move on to the next thing. At the moment, we always select everything. You can see we always select all the fields that we have on product. We select all the fields that we have on brand. To be fair, on brand, we just have 2 fields. So there's not a lot of efficiency gain if we use something like projection. But how will we use projections in this setup? So in the primitives, we also have described the query specifics. So what a selector is, what a predicate is, and what a sort definition is. So these are all combined in a thing that we call the query context. And you can use this query context now through your layers. So you don't have to use the query context if you don't want to. You can also use expressions, right? But the query context combines all of these various expressions like predicate, selector, and sort definition in one object, which is nice to carry around. So let's start with product. Go to our product service here, and then we work through all of our service methods here. So the first one is the get product by ID. We want to have an optional argument here to pass in like the query context. So you can pass on the query context if you're in the GraphQL context or if you're in a context where you know what you want. If you use it with any other API technology like in REST or whatever, you don't have to pass it along. So you just go with the default. So what we're going to do here is we say we want to have a query context for product. And this query context is actually nullable. And let me name that actually query, just to have it a bit shorter here on my screen. And then we can pass this query context to our data loader. And this works the same way like I did down here with the paging arguments. So I can just say with, and then we pass on the query context. Awesome. So this is just passed to our data loader. Then we can go to our data loader, to our product by ID data loader, this guy here, and we can actually just inject it. So we say we want to have the query context for product here. But in this case, we make it not nullable because the data loader source generator will actually ensure that this is always set. If we don't get from the caller a query context, we just initialize an empty query context. So you don't have to deal with if it's null or if it's not null. So how do we apply this? And this is also very simple. You see, I said in the beginning that we do here actually a mapping to our business types. And this means our business layer will give us a query context for product. So we need to ensure that we apply it after we mapped our entity. So we're gonna do a with here, and we say with the query context. And this will ensure that we will apply all the projections or filters or whatnot to this query. Okay, with this we're done. Actually, this would project now, but let's fix first all of our product service before we rerun that. This now works end to end with the query context. Let's actually go back to our product service and let's see for the second thing. This is now done. We go here to get products. That is the root level entry point for GraphQL, and it doesn't have any parameters, so it doesn't need any batching here. So this just EF core, pure as you would use it. And how we would deal with that is, let's first introduce here paging. So we make it page. Then we inject here the paging arguments. And we also use the query context. Again, this is nullable. And actually, because it's nullable, let's make it use the default here. So if we don't pass it in, it's just default, and down here the same. And then we can rewrite that to our paging API. So we use a to-page async here. And then we also make sure that it's ordered always by ID at the end with the then by that we did before. And then we simply use a with like in the data loader. This is an extension method on top of a queryable. So you can just say with query context and everything is done. Okay, this is the second thing also done. Let's do it to our third thing, the batched paging data loader. And it's really the same thing. We just copy this now, pass it down here. Then in the wither, we can actually pass also the query context along. So we say page it and use this query context together in this case. Then we go to our data loader, this guy, and we just inject the query context here as well. And then we also take the with here. Awesome. This is Great. Now we have this integrated end to end. Let's go to our GraphQL types and amend that. So this wants now a query context here. And in GraphQL, we can simply just inject it. So the same way with paging arguments, we can say we want the query context for product, but we also have to register that. So it's not always injected. We have to say we want query context to be injected. So we say add query context, this guy here, and then we can just pass this on, right? Just pass the query context into our business layer and it will work. So let's also quickly go to our product queries here. And there we have the same problem. We need to inject that now. So we're gonna say here, we want a query context. Then we pass that along. And down here, we have to do two things because we also introduced paging to it. So we're gonna say, we're gonna use here a page of product. We inject the paging arguments, and then we also inject here the query context. And then we pass both to our business layer. And at the end, we do to connection async. Okay, yeah, I did one mistake here. This should be connection, right? Not page. Okay, and then we just put here use paging on top. If you ask yourself why we use the connection and not implicitly map page like we do with the cursor paging arcs and stuff like that, that is because you can do a lot more with connection. And you actually want to have a connection because you can extend it. But I'm going to show you about the advanced paging concepts in another episode, right? This episode will be long enough. Okay, let's head on. So this guy is now working. It will return now here our page. And we should now be able to run that. Okay, let's go back here. So we're going to rerun that as is, and it works. Okay, but the SQL here is more complex, and I want to have a look at a simpler version of it. So let's actually just remove that and start from products, right? That is a root level query, so it will be much smaller, this SQL. And we're gonna go here for the nodes. And actually, let's refresh the schema quickly. And then we fetch the name of the product. So very simple. And actually, let's just get the first two here and run this thing. So this just fetches two items here. If we look at this, you can see now it just selects the items that we really use. And this is name and ID. So why ID? Because we have ID in the then by, and from everything that we have in the order context, we need to build a cursor. And that's why if you have something in the order, then it will also be selected so we can build that cursor. That's why we have these two items. So I would have name even if I don't select name explicitly, like if I just select the prices here, we run that, then you can see we always have the two things that we build the cursor from, plus the additional thing here, which is the price. And that's also why in this case, building the same for brand makes not much difference because we always build the cursor from name and ID in the brand case, right? Okay, that works. Like nice, this selection here. But let me show you one thing. We have this product node and you can see I'm going here from the product to brand, right? And I'm doing that by using the brand ID here. Let's go back to our GraphQL API and let's include actually the brand. So we're going to go for the brand. And we ask here for the name. And then we run that. And then you can see brand is now null. Why is that? So let's actually go into debug mode. So I'm putting here a breakpoint. Then we go back to our Nitro instance and we run that. And now it hits our breakpoint here. And when we hover here over brand, you can see it's 0. So what happened is that we only selected the data that was selected in the GraphQL query. And we didn't ask here for the brand ID. We could ask for the brand ID. So we could select brand ID here explicitly. And if we run that again, then you can see brand ID is actually selected. It's 9. And now it would work. And we can see here we have the brand. So the question is here, how do we explain to our projections engine what a resolver actually requires? So with the new parent attribute that we have here, so parent attribute is not new, but it has a new capability to express requirements. So I can actually say, this guy requires to have the brand ID. This is one thing. I could also say this also requires the price. Or I could also even project into the collections of this and say, from the collections I have some things, I want to have the ID. This here is the selection set syntax that you know from GraphQL, but with the properties of .NET. So this is just expressing the most complex things you can do, like with requirements. But in most cases, you just have very simple requirements, right? In this case, it's just a single thing that we want to require. So we can just say, from the product, so name of product, we want to have the brand ID. And this also serves as a requirement. So this requirement tells the projection engine what the requirement of this resolver is from the thing you inject here. So let's rerun this with this thing. I'm going into debug mode again. Now we're going to remove this here and rerun it without the brand ID. And you can see I hit my resolver here and it's still projected. So this now exposes the requirements this resolver has to data of the injected parent here. So with the projections enabled, you now have to specify the requirement every time you use parent. So also here in brand, as I said, for brand, it makes no sense really, but I would always specify it, just that the resolver tells you what it actually needs. In this case, it's from the brand, the ID, right? Awesome. This is it about projections. It just works. You just pass it along. Make sure if you do something like the mapping of entities that the projection is always applied afterwards. Like we map first and then we have our projections on there. With this, let's start with the next topic, and that is sorting. What we want to do now is to give the user of our API the ability to sort the products within our brands and also to sort the products from the top level. So when I go into products, I want to be able to sort them by price or whatever. And in Hot Chocolate, we always had this feature where we could just opt into add sorting. And this now allows me to use the sort middleware on my resolvers. So if I go here to the products queries, I could then just say use sorting, and then we could use the sorting API. It would basically use, if you return the queryable here, rewrite on top of the queryable the actual database query. In our case, we cannot do that because we have no queryable here. We just get an executed page back. So how can we use that? Actually, it already works because it will just add the sort definition into our query context here, and we can use that then down the line in our data loader or directly on the queryable. So let's actually dive in there because we already have an order logic on top of that. So we are going here into the get products, that the root level method that we have in our service layer where we just get the products. And there you can see we have this order by. So first off, there are two aspects here. This is actually our default order that we want to have. So we want to by default order by name, right? And this is a requirement to make the order, whatever order we have, unique. So what we have to do here is to specify that somehow. But we have here this query context. And this query context has something called a sort definition. So the first thing, what we're going to do is introduce an internal class here and let it be static. And we call that ordering. And this is just for convenience, right? Let me put that up here. And what we're going to do here is just introduce a static method, and that will return a sort definition of product. And let's call that default order. And into that method, we're going to pass a sort definition because the sort definition is an immutable. And then we can specify that the sort definition that we get in, if it's empty, so if the user from the outside didn't specify anything, then we want to order our product ascending by the name. But we always want to order it at the end by the ID. Okay, this is our sort definition or our amendment of the sort definition. And we can now use that wherever we interact with the query context by just saying we pass along the default order. We just pass in here basically a rewriter of the sort definition that is on the query context. And if you import here the static class like this here, and we basically just say default order, looks quite nice. And we can move this class out and we have all the sort definition for all our entities specified in this separate internal class here. So now the order is defined here by our query context, and we can get rid of these guys. Let's actually run it. And then we go to Nitro and we rerun this. And it works the same as before. And if we look at the SQL here, you can see that we have here the select name brand ID from the products, right? And this is ordered by name and ID. But we actually changed our schema because we introduced now on the products query here, this sorting middleware. And that means we actually, if we refresh our schema here, we can now pass in the order, and we could order instead of name ascending, we could, for instance, say we want to order by name descending. Let's do this simple thing. Rerun that, go and look at our SQL here. And now you can see order is name descending and then by ID. Or we want to also order it by price ascending on top of that. And then you can see here it's name descending, price ascending, and then ID ascending at the end. This allows you to rewrite the sort definition within your query context and also transparently pass this along for lists. So this works also when we use the data loader. Like in the data loader case, let's go here to the brand node. And there we have the get products here. There we already have here the query context. So we just add now the use sorting here. And then we go to the data loader, this guy here with the 2-batch async. We already have here the query context. The only thing that we want to add is actually our default order. So let's import here with the use static, the ordering, and then we can just say down here, default order, restart our server, go back to the initial query that we had. So we take first 2 in both cases. Let's quickly refresh here and then also pass an order in here. And in this case, we're just going to say we want to order by price, the most expensive thing at the top. We run that and then we can see we don't have the order in here. How unfortunate. But let's go quickly to the data loader. And there you can see you have the order by here again. And this basically resets the order that we have here. So we just need to get rid of this guy. Restart the server, go back here, rerun that, go back here, and then you can see here's the price descending now. Also again, transparently, but in a batch way this time. And also if you have the price here, it also is more visible, right? We can see 249, 199. So it's correctly ordered. Okay, last aspect to this, and that is filtering. And filtering really is the same way like sorting. So we can go here into the program CS. We just add filtering to it. This now adds filtering capabilities. We can go here to the product queries. We just integrate that here, use filtering. And I typically put that always on top of sorting. It doesn't matter, but it's my order that I use in my code, right? Okay, this is actually working. We don't have to do anything in here, because this predicate will be just in the query context. And since we also don't have a default predicate, something that we want to add on here, we can just simply run that and it will work. So we go in here and let's say we want to have a price that is lower than 200, right? So we should have this, but not this. So I'm going here into this guy, not in the order, but actually into the where. Refresh the schema first. Go to the where here. Oh, actually, we didn't implement it on this resolver here. We implemented it on our root resolver. Let's also quickly copy that because it's so simple. We go to brand and we also add it here. Restart, refresh, and now we have the where here. And we can say we want the price to be greater than, to be lower than 200. We run that. So now we get 199 and 129 as our first items. And if we go to the SQL, you can see that we now have the pricing, the where clause integrated here in our where clause of the SQL. So last things to this, because this is not all, and I will have some follow-up episodes where we go into more detailed things, but this should give you a broad picture of how this thing works, right? But there are a couple of hooks you should be aware of. So if we are here, for instance, in the data loader, product data loader, and if we wanted to include something statically that we always want to have for products, right? then we can just say include. So this will always include into your query context. As I said, it's immutable, and we have these extension methods on top where you can simply say always integrate brand ID, not just if it's required. I always need it, right? You can just add it. You could also write a full selector. So you could say, I want to write a selector on top of this, and this will be merged with the selector that is already on there. But be aware, if you write a select and there is no selector on there, it will not be merged, it will replace the null, and that means you only select what you have here. You can also interfere with the where clause. You can, for instance, use the native withers here, and then you could rewrite the predicate, the selector, or the sort definition by hand, right? These are also things that you can do. And the quite nice thing with all of this is, if we just quickly debug that, we rerun that, and you can see I got the interrupt here for my breakpoint. I can just hover over this, and you can cleanly see the expressions that you have on here. These are standard expressions, and we just wrap them into one object together. You could also just inject the selector expression or just the predicate if you want to be more explicit. It's a bit more code because you have more parameters essentially to handle. But this is also possible. So what do you think about our new GreenDonut.Data API? Chime out in the comments, tell us what you think. And as I said, there's more follow-ups coming on this with things around paging, because there's so much more around paging that you can do. But we're going to discover that in another episode. And with this, I'm done. See you next time.